Okay, good day. This is Pre-Calculus. I am Mr. McCully, and this is the non-dual enrollment lesson number 42 on binomial expansion. Let's get right to it. So today we're looking at section 8.4 in the book, so we're bouncing around just a little bit. And we're going to talk about Pascal's triangle and binomial expansion. So we're going to use the binomial theorem to calculate binomial coefficients. We're going to calculate Pascal's triangle as another method to calculate binomial coefficients, and then we're going to write some large binomial expansion. So first thing, let's talk about Pascal's triangle. Now, usually in a classroom setting, I'd have the students try and figure out the order, but since this is a video, I'm just going to show it. So the one different thing about Pascal's triangle than what we would see in a normal counting situation is with Pascal's triangle, you're going to start counting with 0 instead of 1. Normally, when you were a little kid and you learned how to count, you went 1, 2, 3, 4, 5. When we're using Pascal's triangle, we're going to, and I'm just going to put this in here, start counting with 0. All right, so the top row is the 0 row, and so this is the 0 place. The second row is actually the number 1 row, and we count 0, 1. The third row is level 2, and we go 0, 1, 2 as far as the place of these values. Now, in this fourth row, you may notice the pattern already, but the fourth row here is going to be 1, it's going to be a 3, it's going to be a 3, and then it's going to be a 1. The fifth row will be a 1, a 4, a 6, a 4, and a 1. And hopefully you're starting to see the pattern, and the pattern is just this. You take the two numbers that are above the value and you add them to bring it down. You start with 1, you look at the two values above it, and then you bring it down. So I start with my 1, and then I go 1 plus 2 is 3, and then I go 2 plus 1 is 3, and then I end with a 1. I start with a 1, I go 1 plus 3 is 4, go 3 plus 3 is 6, go 3 plus 1 is 4, I end with a 1. All right? And so the last one would be 1, 5, 10, 10, 5, 1. And what this thing does is it calculates the coefficients of a binomial expansion. And a formula to calculate these things is the combinations formula, which we're going to see for the remainder of this section. And combinations NCR has a number of different applications, both in probability and in counting, as well as binomial expansion. That's why we're bringing it. And then I also want you to remember what this exclamation point is. Remember, n exclamation is n factorial. And just a quick example, 5 factorial would be equal to 5 times 4 times 3 times 2 times 1. Okay, so Pascal's triangle is a simple method for finding the coefficients of binomial expansion. It also finds combinations, with a note that when doing combinations, you start counting with 0 instead of the usual 1, which is what we do. And so if I wanted to expand x plus y to the n, I could do that by going n over 1 or n over 0, the combination, so it'll be n and 0 here. And then I go x to the n, y to the 0. Then the next one over will be n chosen one at a time, x to the n minus 1, y to the 1, n over 2, x to the n minus 2, y to the 2, and then it goes all the way down to n over n, because you'll have n terms, to the x to the n minus n, y to the n. Now I know that this is a large and kind of unwieldy thing, but just in general, if you know what these two values are, the first value starts with the exponent, the second value, the y value, starts with a 0, and then as you go to the right, the x value drops down by 1 each time, and the quote-unquote y value goes up by 1 each time. So what does that look like in practical terms? So here I have a 2x minus y to the fifth. All right, so if I want to follow that, I know that my n is equal to 5. So if I want to do this expansion, here's what I'm going to do. It's going to be 5, choose 0. That is always how you start. You start with an n over 0, and then you're going to count out until this bottom number gets to 5. All right, so this first value here, 2x will be to the fifth power. The negative y will be to the 0. Plus, the next term will be 5, chosen one at a time. And then we're going to write the same thing. We're going to go 2x, and we're going to go negative y, except the 2x value gets decreased by 1, and the y value gets increased by 1. So the one after that is going to be 5 chosen 2 at a time. It'll be 2x and then negative y. But this one will be now to the third because I'm going to take the quote-unquote x value and reduce it by 1. And then the quote-unquote y value gets increased by 1. And then it'll be 5, choose 3, 2x to the fourth. Oops, it's got to be reduced by 1. That was a mistake on my part, so let's start over. 5, choose 3. Oh, don't do that. And then it'll be 2x to the second, negative y to the third, plus 5, 4, choosing 4, 2x to the first, negative y to the fourth, and then finally 5, choose 5, and you know you're done when those two numbers match, and it'll be 2x to the 0, and then negative y to the fifth. All right, so we've got to simplify this. Now, the good news is you can use your graphing calculator. I don't have that open, so let's open that while I'm explaining this. All right, so essentially all you have to do is multiply these values out all the way through, and then you're done. Now, I know that that's a lot, but notice this process is going to be a lot easier than taking this and multiplying it out and going 2x minus y times 2x minus y times 2x minus y times 2x minus y times 2x minus y. That's difficult. That takes a lot of time. And I know that this takes a little bit of time, but it doesn't take nearly as much time as that, and you're going to end up with far better results. All right, so we want to learn how to do combinations. Now, if we want to go through and do it correctly, the first one was 5, choose 0. So I'm going to hit the 5 to get that 5, the choose part in there. I'm going to hit the math. I'm going to go over to probability, and you'll notice there's NCR. So if I hit the 3, it's going to put the 5 down where I want it. It's going to put the 0 there. I'm going to hit enter, and it's going to be a 1. Excuse me. So this becomes 1. And then 2x to the fifth, well, that's going to be 2 to the fifth. And 2 to the fifth, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32x to the fifth. And then y to the negative y to the 0 is just going to be a 1 as well. All right, so if I choose 1, I can go to my graphing calculator, I can go second, I can go entry, and we can go over to here, and we can just change that to a 1, and we get 5. So this 5 choose 1 becomes a 5. 2 to the fourth is 16 times x to the fourth times negative y to the first. All right. Well, negative y to the first is just negative y. All right, so 5 choose 2. Well, go second, we'll go entry, and this time we'll change that to a 2. We'll get a 10, all right? So I've got 10. 2 to the third is 8. X to the third. And then negative y times negative y. So negative y squared is just y squared. And then this next one, 5 choose 3. Second entry, we want to change that to a 3. We're going to hit enter there, and we get 10 again. So now we know that we've got the double. It's going to just go back down, and we can go, I'll do them, but you'll notice that the last two will be 5 and then 1. All right, so I've got 10, and then 2 squared is 4. I'll get an x squared, and then negative y to the third is negative y to the third, because when you multiply a negative value by itself 3 times, you stick with a negative. And then 5 choose 4 is going to be 5, but just to prove that I'm right here, I'm going to do a 4 there, hit enter, and get a 5. All right, so I've got 5 times 2x, and then negative y to the fourth is just going to be y to the fourth, because when you multiply a negative by itself 4 times, you get a positive. And then this last value will just be 1. And then 2x to the 0 is also 1. And then when you multiply a negative by itself 5 times, you'll get negative y to the fifth. So now I just need to multiply out. I got a 1 times 32 times 1 is 32x to the fifth. 5 times 16, well, let's see here. 5 times 15 would be, let's see here. Well, let's do it this way. 5 times 10 is 50. 5 times 6 is 30. 10 and 30 is 80. So I'll have 80x to the fourth, and then y, and then I made a slight error here. This negative, it's going to be negative. So when I multiply through, I'm going to have a minus on that term. And then 10 times 8 is also 80. Not 18, Macaulay. 10 times 8 is also 80, x to the third y squared. And then 10 times 4, and this time I'm going to remember I've got a negative y to the third, so it's going to be a subtraction when I'm done. 40x squared y to the third. And then 5 times 2 is 10. Everything's positive, so I'm going to leave it positive. It'll be 10x y to the fourth. And then 1 times negative y to the fifth is minus y to the fifth. And again, I understand that that's not the easiest, most simplest process in the world, but it's certainly far easier than multiplying that out. All right, so for each term in a plus b to the n, you can define that by going n over r, and then this a here is that value to the n minus r, and then raise the b to the r. And then remember, any first term of any binomial expansion begins with the counting with 0. All right, so if I want to do this thing right here, all right, I will have, and they say, given this binomial, 2x minus 3y to the eighth, find the term ax to the fifth, y to the third. Well, if I do that, n over r, a to the n minus r, b to the r, well, in this particular case, it would be 8, and then since the r, we'd have that y, it'll be 8, choose 3, and that will make it 2x to the fifth, and then negative 3y to the third, if I follow this form right there. And then if I go to my graphing calculator, and I go second, or no, I don't want a second, I just want to go math. Math over to probability, type in NCR, I need an 8, I need a 3, this number will get fairly big, 56, not as big as I thought it was going to be. It's got 56, and then 2 to the fifth we did on the last page. 2 to the fifth will be, this won't be an addition, it will be multiplication. it'll be 2 to the 5th was 32, x to the 5th, and then negative 3 raised to the 3rd will be times negative 27, and then I'll have y to the 3rd. So I just have to multiply all this out. And 56 times 32 times negative 27 is negative 48,384. Negative 48,384. Negative 48,384. So I can make sure. 48,384. We're good. And then it'll be x to the 5th, y to the 3rd. And that is our answer there. All right, now they want us to use Pascal's triangle to do the expansion. Okay, well, you may not have memorized it already, and that's okay. I have, but if it's easy to make. I can go 1 1 1 2 1, and then 1 3 3 1 1 4 4. Oh, I added wrong. It's not good. So 1 4 6 4 1. This is the 0, this is 1, this is 2, this is 3, this is 4. So when I raise it to the 4th power, I have this. All right, so just real quickly doing essentially the same thing I did in the first example. It's going to be 1 x to the 4th, 2y to the 0. And I get that 1 from this value right here. And I'm just going to move over each time. So the next one will be 4, and now I reduce the x by 1 and the y by increase it by 1. Then the next one will be 6. It'll be x squared, and then it'll be 2y squared. And then the next one will be a 4 again, and it'll be x, and then it'll be 2y to the 3rd. And then the last one will be a 1 for the leading coefficient. It'll be x to the 0, and 2y to the 4th. And so 1, and that's expression is going to be 1. And so I'll have x to the 4th, and then 4 times 2 gives me an 8, x to the 3rd y, and then 6 times, well, it'll be 2 squared. So because this will be 4y squared. So 4 times 6 is 24x squared, y squared, and then 4 times 2 to the 3rd. Well, 2 to the 3rd is going to be 8. And so 4 times 8 is going to be 32x y to the 3rd, and then 1 times 1, and then 2 to the 4th will be 16y to the 4th as my final answer to that. All right, that's all I got for today, folks. So the Star Wars fun fact of the day: in Star Wars The Mandalorian, the Mando's phase blaster was patterned from a weapon that was used by an animated Boba Fett from the 1977 Star Wars Holiday Special. Talk about a throwback. That is, if my count is correct, 43 years old. Yep, that sounds about right. That's all I got, folks. Bye.